Hi, this is Camelia and Carrie, and today we'll be talking about Tofersen for ALS. Meet Lou, Stephen, and Darlene, three incredibly different lives with one thing in common: ALS. Lou Gehrig, a baseball legend, Stephen Hawking, a world-renowned physicist, and Darlene, Carrie's beloved grandma. All were diagnosed with ALS, a progressive neurodegenerative disease that eventually takes away your ability to move, speak, and breathe. They each started noticing muscle weakness, slower speech, and difficulty performing daily activities. After weeks of tests, doctors diagnosed them with amyotrophic lateral sclerosis, a fatal, incurable disease that affects nerve cells in the brain and spinal cord. The disease worsens over time. The average life expectancy after diagnosis is about 2 to 5 years. It's often called Lou Gehrig's disease, named after the baseball player who helped bring public awareness to the condition. ALS usually starts in the hands, feet, arms, or legs and then spreads to other areas. As more motor neurons die, muscles weaken, making it harder to walk, speak, swallow, and eventually breathe. ALS can really affect anyone, but certain risk factors increase the chances, such as age, sex, and genetics. It's most common between ages 60 and 80. Men are slightly more likely to develop ALS before age 65, and about 10% of ALS cases are familial, meaning a genetic mutation is passed down. As for symptoms, they can start subtly, but yet get progressively worse. Some examples of some symptoms of ALS are tripping and falling, trouble walking or doing usual activities, weakness in legs, feet, or ankles, hand weakness or clumsiness, slurred speech or trouble swallowing, weakness associated with muscle cramps and twitching in the arms, shoulders, and tongue, crying, laughing, or yawning, and thinking or behavioral changes. One of the most studied genetic causes of ALS is a mutation in the SOD1 gene, short for superoxide dismutase 1. This gene encodes an enzyme responsible for breaking down superoxide, an unstable byproduct of cellular respiration that causes oxidative damage when it builds up. SOD1 normally protects cells by converting superoxide into safer molecules like hydrogen peroxide and oxygen. But with mutations like the I113T mutation shown in the 3ECV crystal structure, SOD1 misfolds and clumps together, becoming toxic to motor neurons. Here are a few structural highlights of SOD1. It's made of 153 amino acids. It has 2 identical subunits that are held together by hydrophobic interactions which stabilize the structure. Each monomer forms an 8-stranded anti-parallel beta barrel. It has 4 metal binding sites, 2 copper and 2 zinc in total. A disulfide bond between C57 and C146 adds additional stability but can also contribute to aggregation if the protein is mutated. When this balance breaks down, misfolded SOD1 proteins aggregate, leading to the destruction of motor neurons and contributing to ALS.
So SOD1 is obviously a really important enzyme. We all need it, we all have it, and we all use it. We use it in its holoprotein form. That's when it's active, which means it's doing its job, neutralizing the superoxide radicals, and it's really, really stable. It's really stable because each subunit is bound to the copper and the zinc, and those metals allow it to hold its shape. The problem is the apoprotein form. The apoprotein form has no bound ligands, which means no metals attached to it, and that makes it both inactive, so it's not doing its job, and it's not as stable, which means it's probably more likely to miss folding, which is an issue, as we will see. So since SOD1 gets its stability and function from binding 2 key metals, the zinc is what stabilizes the protein, and the copper is kind of what does the action. This is a close-up of the zinc binding site. You can see that it's bound to 3 rings. Those are histidine rings, and it's bound to 1 not ring, which is an aspartate. Those allow the zinc to be really stable, which makes the protein structure really stable. This is a close-up of the copper binding site. It's bound by 4 histidines. You see 4 rings because it's in its oxidized copper 2+ state. When it reduces to copper plus, the binding gets a little bit looser and 1 histidine leaves for a bit. So the point of SOD1 is it works by the copper switching back and forth from 2+ to 1+ states. And so at some points it's going to have 4, at some points it's going to have 3, and that's just how the action happens. These really precise metal interactions are what keep SOD1 functional and folded until mutations or metal loss tip it into chaos. And now, if we all use SOD1, how come only some people have ALS? Well, the people with ALS have mutated SOD1 proteins, and that happens when a protein is misfolded. Misfolding usually, not always, but usually happens in the apoprotein form because since it's missing its metals, it's way likely to misfold because it's just weak. And then it usually happens in the disulfide bond, which, if you'll recall, is the part that holds both subunits together, which is really important. So if the apoprotein is already weaker, and then the disulfide bond gets weaker, the whole thing gets wobbly, it just falls apart, and it folds in all kinds of directions. When it misfolds, part of the protein that should stay hidden, like the hydrophobic regions in the middle, get exposed, and they're really sticky. So they stick together in clumps, and that's called aggregation. Aggregation happens inside motor neurons and astrocytes, and that buildup is what drives ALS progression. It's not just one bad apple. These toxic proteins mess with cellular function, leading to neurodegeneration and ultimately the muscle weakness that we see in ALS patients. Okay, so what do? We now have Tofersen, which is the very first disease-modifying therapy for ALS. It's an investigational drug that's specifically designed to treat the mutations in SOD1 proteins. It latches directly onto SOD1 mRNA, and once it binds, it signals for RNase H to come in and chop up the mRNA, which stops the cell from making more mutant SOD1 proteins. That means there's less toxic SOD1 floating around the cerebrospinal fluid and blood, and hopefully that means a slower disease progression for people with SOD1-linked ALS. This is the structure of Tofersen. It is a 20-base antisense oligonucleotide, or ASO. It uses a gapmer design, which is a short antisense strand with chemically modified ends. The outer 5 sugar units on each end, that's the pink part, are 2,O-methoxyethylribose, and those protect the molecule from degradation. The central 10 sugars, the green part, are normal 2-deoxy-D-ribose, which is what allows the RNase H to bind and do its job. This structure makes Tofersen both stable in the body and resistant to nucleases and able to knock down the target mRNA really, really efficiently. Of course, a drug like Tofersen isn't cheap. It requires an intense dosing schedule, 1 dose every 2 weeks for the first 6 weeks, and then monthly maintenance. It clocks in around $200,000 per year. And that's not even including the things you need for ALS life, like the motorized wheelchair, or the chair that helps you sit down, or all the modifications you're going to need for your bathroom, or the reclining bed, or the fancy toothbrush, things that you would never imagine. So these people are spending so much money, and most people can't afford it, which is why community organizations and the ALS Association are really, really important. But you remember that ice bucket challenge from like 10 years ago? It wasn't just a social media trend. That alone raised over $100 million in just the first month. And some of that funding directly supported the development of Tofersen and other ALS breakthroughs. And personally, a lot of that money went to the care of my grandma, which I really appreciate. So, in a way, your friends dumping cold water on their heads in 2014 may have just been funny, but really, it helped give a few more years to another future sports star, brilliant scientist, or, most importantly in my opinion, let somebody else have a couple more years with their grandma.